Assalamualaikum and hi, my name is Muhammad Abib bin Rosman, Novometric DD220092. We'll be presenting about the introduction of motion in space, vector valued function. Okay, so when a particle moves through space during a time interval I, we can think of the particle coordinates as functions defined on I. So let's take a look at the equation. X equal to f of t, y equals to g of t, and z equals to h of t, in which t is set of I. So the coordinates x, y, and z is equal to f of t, g of t, h of t, which means the same equation as above. So for the equation, it defined the particle parts, or we can say it parameterized the curve. So for s to represent the curve as vector form, we use different equations, which is r of t equals to vector op f of t I component I plus g of t component j plus h of t component k. Okay, so for a clear insight, we can see the diagram here. So this is the O, which is the origin, and this is the point P. So the function of using the vector form, we can trace where is the point of P, um, in which the R we can insert the I value to get the vector values. So the variables will be determined by the I value, and there are difference for every variables. That's all from me. Thank you.
Hi, good day everyone. In this example, we given the position of a particle in the xy plane at time t is rt equal to t plus 1 for component I plus t square minus 1 for component j. Find an equation in x and y whose graph is the path of the particle, then find the particle velocity and acceleration vector at t equal 1. This is so really three separate tasks that we asked to do. We are giving vector value functions rt equal to t plus 1 for I plus t square minus 1 for j. Remember I component as a x function. So x equal to t plus 1 and y equal to t square minus 1 because I component is a y function. In order to find x and y, we will solve x sub x function for t if we subject from both sides will be t equal x minus 1 and we relate to x and y. To relate x and y, plug in t x minus 1 to y equation will be y equal to x minus 1 square minus 1. That's equation whose graph of this function in this part of the particle. For the second part of the problem, find the particle velocity and acceleration vector at t equals 1. We know that velocity vt equal to r prime t, that derivative equations. So the derivative equation is vt equal to r prime t equal to d over dt t plus 1 for I component plus d over dt t square minus 1 for j component. Take derivative 1i plus 2tj. We use a simple derivative power rule and now plug in 1 for t. v1 equal to I plus 2j. Acceleration is equal to velocity. At equal to v prime t equal to d over dt 1i plus d over dt 2t for component j equal to 0I plus 2j. Plug in a 1 for t, but there are no t for equation, so we get a1 plus 2I. This is going same acceleration at any time on that curve. Thank you.
Example 2. The equation r of t equal exponent the power of negative ti plus 2 cos of 3tj plus 2 sin 3tk is the position of particle in space at time t. Find the particle's velocity and acceleration vector, then write the particles velocity at t equal to 0 as a product of its speed and direction. First of all, we need to find the particle's velocity and acceleration vector. For the velocity, v of t equal to r prime of t, and the equal to d over dt exponent the power of ti plus d over dt 2 cos 3tj plus d over dt 2 sin 3tk. And then after we put the value in the formula, resolve the equation, and then we get the dt or d over dt of exponent the power of negative t is negative exponent power of negative ti, and for the 2 cos 3tj is negative 6 sin 3tj, and for the 2 sin 3t we get the 6 cos 3tk. This is a 4 velocity function. For the acceleration, a of t is equal to v prime of t. The formula, the equation is we take from the velocity equation, and the answer we get is e the power of negative ti plus negative 18 cos 3tj plus negative 18 sin 3tk. So after that we need to find the particle's velocity t or equal 0 as a product of its speed and direction. So we already found the velocity equal negative exponent the power of negative ti plus negative 6 sin 3tj plus 6 cos 3tk. And then we put the value in the t change to 0, and then we get for the I is negative 1i and j is 0j, and the last and for the c is 6k. And after that find this we need to find the speed using the formula magnitude v 0 is equal to square root 1 plus 0 plus 36, and then plus the all of value, and the answer is square root 37. And then and then v of t is equal to square root 37 times negative 1 over square root 37i plus 6 over square root 37k. And for the in front or in the speed is the value of speed, and then for the value of speed is 30 square root 37, and for the direction negative 1 over square root 37i plus 6 over square root 37k. Thank you.